Now that we calculated the location of the centroid, which is this, for the entire section, and we had the y bar is equal to 3.3 something, and the reference point already was 8, so we add 8 to the 3, we got 11.3. The x is minus 0.79, which is somewhere around here, so we'll take that into consideration as we do our calculation. It might not be shown because it is tiny. Now let's start with the first element, which is this guy, W12 by 93, and to calculate the location of course we, in the centroid, we were measuring the x and y from the reference point, which was this one previously, but when we do the calculation of moment of inertia, our reference point becomes the centroid, which is this one. So same thing, the only difference is we call the x distance dx and we call the y distance dy. So we need to calculate these ones also, we need to measure them. So for the I-beam, I need to find the x distance, which is this here. It coincides with this one, there is no x. The x is just minus 0.0079. That was the x bar, because this x bar is measured from the center of the web, and the y distance will be the vertical distance between the centroid of the I-beam and the centroid of the entire thing, this distance. So to calculate this, we need to have 11.3, this distance, minus this distance, which is this distance is d by 2. That is the calculation that I followed. So let's take a look at the calculation part here. The x is minus 0.079, and the y distance is 11.3 minus half of the depth, like we have mentioned. Now for this channel, let's take a look at the sketch. For this channel, the x distance is from here till here, somewhere around here. So it will be the x distance of the channel, which is from here to here, plus the distance half of the thickness of the web here, plus the 0.079, because we like to get the distance from here till the location of the, so it is 3 pieces. It is the x distance of the channel, which is till the edge, and then half of the thickness of the web, then the 0.079. That is for the x. And in the case of moment of inertia, it doesn't matter the negative and positives, because you'll see in the equation it is squared always. It is the dy and dx are squared, so regardless of the positive negative, it will be okay. So for this part, we have the x will be equal to 0.7, half of the, this is the x, and this is half of the thickness of the web, and this is the 0.079, like I mentioned. That's for the x. Now for the y, we need to get this is the distance that we would like to get from here to here. So to get this distance, I would go to the entire distance from here to here, which is the depth of the section, 21 something. Then I'll subtract this thickness of the flange, which is 0.93. Then I'll be left with the distance from here to here. Then if I subtract this distance, which is the x or y, I'll be left with the distance from here to here. And if I subtract this distance, I'll get the distance from here to here, which is what I want. Well, this is valid for this angle, and it will be valid same thing for this channel. The only difference is instead of this guy, you use this guy, which is depth by 2. Same concept, exact same thing what I used here. So again, for the channel, I will get the distance, the entire distance from here to here, subtract this distance, which is the thickness of the flange, and then subtract this half of the depth of the channel. So I'll be left with distance from here to here. Subtract this from it, you'll get this one. Like I said, applies the same thing to this one, except this is the distance that you need to different. Anyway, the calculation will reflect all of this explanation, so I'll go to that. I'll try to, as I remember the numbers, tell you interpretation for that one. So let's go to the calculation part. So for this, for this guy, use pink. The depth, the entire depth, that is for the beam, the flange thickness, and then half of the depth of the channel, like I said, and then minus the y bar, the distance from the bottom to the centroid. And if you wanna, while we're on it, same goes here. This is the entire depth. This is the flange of the beam, and this is the y or x bar because it's equileg, and then this is the y bar. So story is same for both of these. Now for x distance, this will be the, again, this will be positive, so this will be the x distance, half of the thickness of the web, and this is the 0.0079. And same goes for this. It is the x distance, half of thickness of the web, and it's 0.0079, but this will be minus. Let me just go back to the sketch. Yeah. So when we calculate this distance, let me just make this a bit larger. So when I calculate this distance, the x for this one will be from here to here. This will be the x distance, and then you have this is the half of thickness of the web, and of course the center is somewhere here, which is 0.079. So these three pieces will be the x distance for the channel. Now for the angle, for this angle, it is distance from here to here, that is 1, then half of the thickness of the web. I'm adding these ones, then you have to subtract from the location of 0.079. So you subtract that because it is towards this side. Okay, so just that is the difference. So if you make this a bit larger, maybe you can see these things better. Then last thing left for us is this channel, this angle line at the bottom. And again, we need to get the x distance from here to here. Same story. It will be this x distance plus half the thickness of the web minus 0.079. That's for the x. And for y, the distance is from here to here. If you want to consider this in the minus will be fine, but because you're going to be squaring this, so the minus will have no value. And that will be straightforward. You'll have this distance minus this distance minus this thickness of the flange. So if we go to the sketch, we should be able to see these. Back to the sketch. Start to the calculation. So here we go. The y is, like we said, 11.3 minus the y distance and then the thickness of the flange, and the x will be the x distance, half of thickness of the web, minus 0.0079. Now once you get the sum of areas, sum of moment of inertia for each component, and sum of area multiplied by dy squared, and sum of moment of inertia about y, and sum of areas multiplied by dx squared. Once you get these values, just substitute them in the equation here for x, which is sum of all x is 2, this one, and the sum of all area multiplied by dy squared is this, so you get the value here. And to do the y, same story, you have the equation, and the sum of all IYC's, which is this one, and then you have sum of area multiplied by dx squared, which is this one. These are the, so as you can see from the moment of inertia for about x is 2970, and for x about y is 132 y less.